Welcome, everyone. I'm excited to kick off today's presentation on practical geometry. This is the cover slide, so I just want to briefly introduce the topic. Our focus will be on how geometry applies to real-world situations and problem-solving. We'll explore key concepts, useful techniques, and practical examples. So, let's get started and discover how geometry is truly useful in everyday life. Let's take a closer look at the contents of this section. Here, we're exploring different scenarios for constructing a quadrilateral based on the information given. The first case is when we know the lengths of all four sides plus one diagonal. This situation allows us to apply specific methods to determine the shape and size of the quadrilateral accurately. Next, we move to the situation where two adjacent sides and three angles are known. This case is quite common, especially when working with partial measurements, and it requires understanding how angles and sides influence the overall shape. Then, there's the scenario where two diagonals and three sides are given. This setup can be a bit more complex, but it provides enough information to construct the quadrilateral with precision. Finally, we consider when three sides and two included angles are known. This is a very practical case, often encountered in real-world problems, where a mix of sides and angles guides the construction process. Throughout this presentation, the key idea is understanding how different combinations of known measurements can be used to accurately construct any quadrilateral. Recognizing these scenarios helps us apply the right techniques efficiently, tying into the overall theme of mastering geometric constructions. Let's start by exploring what geometry really is. At its core, geometry is a branch of mathematics that focuses on questions about the shape, size, and position of different figures. It also deals with the properties of space around us. When we think about geometry, we're essentially asking how objects relate to each other in space, how big they are, how they fit together, and how they are positioned. Now, the word geometry actually comes from the ancient Greek language. It's derived from the word gamma epsilon omega mu epsilon tau rho o to alpha, which is pronounced geometron. Breaking that down, geo means earth and metron means measurement. So originally, geometry was about measuring the earth, like land boundaries or the surface of the earth itself. This historical root ties directly to the overall theme of our presentation, understanding the fundamental principles of space and shapes, which are essential in both everyday life and various fields like architecture, engineering, and art. So, as we go through this presentation, keep in mind that geometry isn't just about abstract shapes. It's about how we understand and measure the world around us. Now, let's explore how to construct a quadrilateral when given different sets of measurements. First, imagine you know four sides and just one diagonal. This gives you a lot to work with, and we'll see how to piece it all together. Next, if you have three sides along with two included angles, that opens up another method of construction, allowing us to determine the shape precisely. Then, there's the scenario where two diagonals and three sides are provided. This might seem more complex, but with the right approach, it's totally manageable. Sometimes, we also work with special properties of quadrilaterals, like symmetry or parallel sides, which can simplify the process. Lastly, if you're given two adjacent sides and three angles, you can use those measurements to accurately construct the quadrilateral as well. Connecting all these different cases back to our overall theme, the key idea is that understanding what measurements are given guides us in choosing the right construction method. Each set of given data unlocks a specific pathway to accurately drawing the quadrilateral, making this a versatile and essential skill in geometry. Now, let's look at how we construct this quadrilateral when we know the lengths of four sides and a diagonal. I'll walk you through an example to make it clearer. First, we'll construct a quadrilateral named PQRS with the given measurements. PQ is 4 centimeters, QR is 6 centimeters, RS is 5 centimeters, PS is 5.5 centimeters, and the diagonal PR is 7 centimeters. To start, draw a rough sketch of the quadrilateral based on these measurements. It doesn't have to be perfect, just a basic shape to guide us. Next, we focus on constructing triangle PQR, because from the measurements, it's straightforward using the SSS, or side-side-side construction rule. Draw triangle PQR accordingly. Now, moving on to locate point S, we know that S should be on the side opposite to Q relative to the diagonal PR. For this, we have two key measurements. S is 5.5 centimeters from P, and S is 5 centimeters away from R. Let's start with the measurement from R with R as the center. Draw an arc with a radius of 5 centimeters. This arc represents all the possible points that are 5 centimeters from R. Next, from P, draw another arc with a radius of 5.5 centimeters. The point S must lie somewhere on this arc, since S is 5.5 centimeters from P. The crucial part is finding where S is located. S should be on both of these arcs, so where they intersect will give us the exact position of S. Mark the intersection point as S. Finally, connect S to the other vertices, and you'll have completed the quadrilateral PQRS. This process highlights how knowing specific side lengths and a diagonal allows us to construct the entire shape accurately. Now, let's walk through an example to understand this construction when 2 diagonals and 3 sides are given. We start by constructing a quadrilateral ABCD with specific measurements. BC equals 4.5 centimeters, AD equals 5.5 centimeters, CD equals 5 centimeters, diagonal AC is 5.5 centimeters, and diagonal BD is 7 centimeters. First, I recommend drawing a rough sketch of the quadrilateral to visualize these measurements. Step 1. Construct triangle ACD using the side-side-side, or SSS, method because we know all 3 sides, AC, AD, and CD. Once that's done, our goal is to locate point B, which is at a distance of 4.5 centimeters from C and 7 centimeters from D. Next, step 2. With D as the center, draw an arc with a radius of 7 centimeters. And then, step 3. With C as the center, draw another arc with a radius of 4.5 centimeters. The key insight here is that point B must lie on both of these arcs, since it's the point that satisfies both distance conditions. Finally, step 4. Find the intersection point of these 2 arcs, mark it as B, and then complete the quadrilateral ABCD. This intersection point B is crucial because it ensures all the given lengths and diagonals are satisfied, making ABCD the quadrilateral we need. This method highlights how geometric constructions can be precise and elegant, especially when working with given diagonals and sides. Now, let's see how we construct a quadrilateral when we know 2 adjacent sides and 3 angles. I'll walk you through an example to make this clearer. We need to construct quadrilateral MIST, where MI is 3.5 centimeters, is 6.5 centimeters, and the angles at M, I, and S are 75 degrees, 105 degrees, and 120 degrees respectively. First, I recommend drawing a rough sketch of the quadrilateral to visualize the shape. In step 1, we consider how to locate the points. The key question is, what should we choose as our base and what's our first move? Once we have that, we can proceed systematically. Moving to step 2, we make an angle of 120 degrees at point S, specifically ICSE. This helps us set up the correct orientation for our construction. Next, in step 3, we construct IMs equal to 75 degrees at point M. As we do this, we see where the lines SY and MZ intersect. That intersection point is marked as T. Finally, once all these steps are completed, we find that the quadrilateral MIST is properly constructed. This process highlights the importance of using known sides and angles to accurately determine the entire shape. Now, let's look at what happens when we are given 3 sides and 2 included angles in a problem. To make this clearer, I'll walk you through an example of constructing such a quadrilateral. First, we'll construct quadrilateral ABCD, where we know that AB measures 4 centimeters, BC is 5 centimeters, CD is 6.5 centimeters, angle B is 105 degrees, and angle C is 80 degrees. Start by drawing a rough sketch of the quadrilateral to visualize the problem. Step 1. Begin with segment BC, measuring 5 centimeters, and place it on your paper with B and C appropriately. Then, Draw an angle of 105 degrees along a line from B, which we can call BX. Next, locate point A by measuring 4 centimeters from B along this angle, ensuring it aligns properly. Now, you have points A, B, and C positioned. Moving to step 2, the point D will be on a line called CY, which is inclined at 80 degrees to BC. To do this, at point C, construct an angle of 80 degrees to BC, ensuring that the line CY makes this angle with BC. Then, in step 3, from C as the center, draw an arc of length 6.5 centimeters, representing the distance CD. This arc will intersect the line CY at point D. Finally, in step 4, complete the quadrilateral ABCD by connecting D to A, forming the required shape. And there you have it, ABCD, the quadrilateral constructed based on 3 sides and 2 included angles. This method highlights how combining given lengths and angles allows us to accurately build complex shapes, which is a key part of understanding geometric construction techniques.